Hello, everyone. Welcome to my channel. Today, we're going to be discussing a very important concept known as recurring decimals. And I'll teach you different hacks on how to solve these kind of questions. Having said this, let's get started. So, again, what exactly does it mean when I say the word recurring decimals? For example, we could say that we have this kind of question 0.444 dot. This actually means that this number 4 is being repeated more than once, and it keeps getting repeated infinitely. So I can write it down as 0.4, and then I might place a dot on it. This is again one way of expressing this. Otherwise, the question might be given to you in this way as well. Line or dot has the same meaning. It means this number is getting repeated. So we will be dealing on how to convert these kind of questions into a fraction. But it's very important to know on what type of questions can we get in the exam. So the very first kind of question, which is quite basic, is something that is known as pure recurring numbers, pure recurring decimals. And the second type of question will be based on mixed recurring decimals. Now, whenever I talk about pure recurring decimals, that means I'm only having something like this, perhaps 0.4, and then there's a dot on it, or perhaps I might even have 0.44 and then two dots on it. I might as well have something like this, 0.123 dot. Again, I can express this with a dot as well, or I might as well write this down as 123 and then a line on top of it. They both have the same meaning, so it doesn't really matter. The second kind of question is based on when you have something which requires a mix of both. What I'm trying to tell you over here is that we might have a question which looks like this, 0.14 dot. Now, you might as well probably observe that there's something that's different, right? So we have something which is, again, a non-recurring part, and then we have this number that is getting repeated. So if I were to write down this number, that actually means it's 0.1444, and the list goes on and on. So hopefully now you understand as to what type of questions you might come across in the exam. You might have something that looks like this as well. Again, what does that mean? 0.2 and then threes, which keep going on till infinity. So I'll be breaking this lesson into two different parts. The first will be discussing the pure recurring decimals, and then we'll be moving towards the mixed recurring decimals. All right, now let's get started. All right. So when I talk about pure recurring decimals, let's take this example. Example is going to be perhaps we have a number 0.3 and then there is a dot on it. Now, the key over here or the hack that I'm trying to teach you over here is that depending on as to which number or how many numbers are being repeated, in this case, I can clearly see that it's the same number 3 that keeps getting repeated infinitely. So always in these kind of questions, you might want to start off with saying that there is a value x, which is actually 0.3 dot. So I'm actually assuming that this number, the question that they've given us, is something that is taken out as x. Now, once I've done this, the next task is to always multiply with something in the power of 10. Now, what is that supposed to mean? In this case, how many recurring, or I should say, how many recurring numbers do you see? It's just one number that is getting repeated infinitely, right? So the idea is that you multiply this by 10. If I multiply both sides by 10, what does that give me? 10x equals to 3. Again, can I write this down as perhaps 0.3333? The list goes on and on, right? So when I multiply this side by 10, as in imagine that you're multiplying this thing by 10. What does that give you? 3.3333, and the list goes on and on. Is it possible for me to write down the same expression as 10x equals to 3.3 dot 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 dot? I mean, don't you think this has the same meaning, right? Expressing 3.3 dot has the same meaning as 3.333333. Now that we've already stated this, I can actually just subtract this. That means if I were to subtract 10x minus x, now let me ask you this. What's the value of 10x? This has to be 3.3, and then we have a dot on it. In a similar way, what does x represent? This would be minus 0.3, and then we have a dot on it. So the key over here, if I were to perform the subtraction, this is what's happening. 3.3 dot minus 0.3 dot. This 3 dot and this 3 dot, they both cancel out, leaving you with just 0. And then we have a decimal over here. 3 minus 0 gives you 3. That means I can write down this expression as just 3, because this 0.33333 and this 0.3333, they both got subtracted. So I'm only left with 3 as a whole number. 10x minus x is going to leave you with 9x, and x equals to 3 over 9, which does simplify to 1 over 3. That's it. If you were to put this in your calculator, you'll see that we get the same answer as 0.3333, or whatever the question was given to us as in this form. So hopefully this concept about pure recurring decimals for at least one, I would say, recurring number is clear. Now we'll move on to another example. This example consists of something that can be written in this way. So now let's talk about pure again, pure recurring numbers or pure recurring decimals. But now in this case, we're having two numbers which are being repeated. So in this case, let's say that we have a question which is 0.23, and then I have a dot on both of them. Now in this case, I can easily see that it's, again, how can I write down this? What does that mean? It means 0.23, then we have 23, then we have 23. And this pattern of numbers keeps on repeating infinitely. So hopefully now the question is clear as to how or what this question actually means, right? So again, we'll get started off by saying that x equals to 0.23, and then we'll place a dot on it. That's what's again given to us. In this question over here, like I said, you have to multiply in powers of 10. I never said the word 10 because you need to realize in this question over here, how many numbers do you think are being repeated? As in, I know it's 0.232323, but how many numbers do you think we have? So we have two numbers over here. Again, the hack is multiply it with 100 now. So if I were to multiply this by 100, that's going to be 100x on this side. But again, how can I write down this? It's 0.232323, and the list goes on and on. So when I multiply the right side by 100, that means now I'll be having 23.23232323. The list again goes on and on. Would I write down this as 100x equals to 23.23, and then I can place the dot on it? You might have a question as to why we are not placing the dot on this side. We can, but we need to imply, as in we need to get rid of this 0.23 dot that we have after the decimal. That's the main reason for doing it this way. All right, so that's what we get. Again, let's start subtraction. So 100x minus x. What does 100x represent? 23.2 dot 3 dot minus, again, 0.23. So again, the key over here, if I were to perform my subtraction separately, this will be 23.23 minus 0.23. So you need to realize that you have to align these numbers, as in exactly below them. I've seen some students making this kind of mistake. They write down the number in this way. That's wrong. Again, you have to make sure that the decimal must be exactly below the same decimal as well. So anyways, that's going to be 2, 3. So again, if I subtract this ends up giving me 0 on this side. And then 23 minus 0 gives you 23. 23.0 is the same thing as just 23. So I'll write down this as 23. In a similar way, that's going to be 100x minus x. That's going to be 99x. And then since I need to figure out x, that means now I'm left with 23 over 99. That's it. This right here is my answer. So hopefully the rudimentary concept by now is clear. In a very similar way, if I were to ask you, what if I had 0.123 dot? Again, in this case, how many numbers do I have? We have 3 numbers. So just like the same hack that I told you, you will be multiplying this by 1000x. Hopefully the key is now clear as to what you should be multiplying. Yes, there are ways of doing this, as in by multiplying it by a million or multiplying it by 10,000. But you need to realize that these questions are meant to be done without calculator. And the idea is that you should be, as in selecting numbers which are easy for us to calculate. So hopefully this part is now addressed. I don't think I should be doing this, but I would love to see the answer to this kind of question in the comments. Having said this, now we'll be moving on to another part. All right, so now let's discuss the second type of question that we can get in this topic, which is again the mixed recurring decimals. Mixed recurring decimals. Now, in this case over here, it's kind of easy to understand. Now that you have the basic rudimentary concept as to how we deal with pure, I would say, recurring numbers, this one is quite similar to that. Anyways, let's check this out. So let's say we have a question which is 0.13. But in this case, I'm actually making this very clear that it's 3 that is being repeated. So again, how can I write down this as in what does that mean? This actually means that we have 0.13333. That's how, again, this actually looks. Now that we have already understood what the question means, we can express this as my x. And again, the key over here is to get rid of this number that is being repeated. And somehow we should be subtracting something, which kind of just makes our job easier, or somehow we can easily get rid of this. So again, in this case, I will be multiplying this by 10. Why should I multiply this by 10? Because there's only one number that is being repeated. So if that is the case over here, and if I do multiply this by 10, again, let's try to understand this number. So is it possible for me to write it down in this way? Of course it is. Now, if I multiply both sides by 10, that means I'll be having this side as 10x, and this side on this, as in on the right side, this would become actually 1.333. Try to multiply this by 10, ... which means that I can actually represent this number as 10x equals to 1.33 and then dot. Now, I'm sure some of you might have this question as to why is it that I've actually placed the dot on the second 3? Why not on this one? The key, again, like I said, is to subtract. And you'll see you'll see why I've done this just in a short while. Now, in this case over here, let's try subtraction. 10x minus x. This will be 1.33 dot minus we have 0.13 dot. Now, in this case over here, let's try the subtraction separately. 1.33 dot, and then we got 0.13 dot. You see what's happening? If I had only written this 3, then you won't be able to subtract because it's the second decimal number that is being repeated. So hopefully this is now clear as to why did I expand this all the way for 2 decimal places. 3 dot, and then this 3 dot cancels out, which leaves you with 0. 3 minus 1, that's going to be 2. 1 minus 0, that's going to be 1. That means I'm actually left with 1.2 on this side. And on the left side, we're having 10x minus x gives you 9x. Now, in this case over here, I can easily, divide this by 9 on both sides. But the key over here is to write down the answer as a fraction. So in these kind of questions, it is usually advisable to multiply this by another 10. If I did, that's going to leave me with 90x equals to 12, right? Because I'm multiplying 10 on both sides. So if that is the case over here, that means I can write it down as 12 over 90. And this would simplify to 2 over 15. So that's going to be my final answer over here. This is, again, I would say method 1 of solving this. Am I a big fan of this? Generally, I would say that there's no such, I wouldn't say there's like method 1 and method 2. I'm just telling you that there's different ways to approach this kind of question. So let's solve the same question using another method. Now, in this case over here, I would take this as method 2. Method 2. Again, the first step remains the same, that we would write it down as 0.13 dot as my x. Instead of multiplying this by 10, I could actually multiply this by 100 instantly. Now, why should I multiply this by 100? Again, you'll probably see the idea behind it just in a small while. Now, again, what does that mean? Like I said, 0.1333333. If you were to multiply this by 100, that means we'll be having 100x equals to 2 decimals will be moved on this side. That means that's going to be 13.333333. Or in other words, I can write it down as 100x equals to 13.3 and then 3 and then dot on it. This is the expression that I end up getting. If that is the case, let's try subtraction. 10x, 100x minus x equals to 13.33 dot minus 0.13 dot. If you subtracted this 13.33 dot minus 0.13 dot, you'll realize this and this cancels out. 3 minus 1 is 2. 13 minus, this is going to be 13.2. And then we'll be having 99x. In this case over here, you need to realize that you can easily solve this as well. So again, I multiply this by 10. That's going to be 132, but this side is going to be 990x. In this case, again, if you were to simplify this, we still end up getting the answer as 2 over 15. Will I recommend this approach? No. But I want you to know that if you check out online videos as well, you'll see that there's different ways to approach these kind of questions. Usually the best way is the first one. Like I said, you multiply this by 10. And if you feel like there's something more that you have to multiply, you can always add, as in you can always multiply 10 on both sides while you're doing this. I'm just saying this approach is kind of safe. You get to, as in you don't have to experiment much to actually reach to your final answer. There's also another way of doing this as well, but I'd rather not teach you because I don't want to make this too overcomplicated. So let's have a look at this, past paper question that we have. The question reads, write 0.146 as a fraction in its simplest form. You must show all your working. Again, what does that mean? It actually means that this number over here is 146, 46, 46, 46. I'm not sure if you can actually see this, but the idea is that it's 46 that is getting repeated. So we need to exactly, replicate the same number again and again, dot, 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 dot. So again, that also goes till infinity. Let me start by asking this. How many numbers do you think we have which are recurring decimals? I'm sure you can probably observe by now that it's going to be just 2. So what should I do in case when I have only 2 numbers? You should be multiplying this by 100. So if I did multiply this by 100, 100x, don't you think that's going to be 14.6? What else do we have? 46, 46, 46, dot, 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 dot. So in other words, if I were to simplify my working, 14.646, and I can just place a dot on these 2 numbers. You don't need to write down this step, as in this step is not required, nor is this one. So why did we write this down in the first place? To again help you understand this question better. Now, hopefully you can see that we're having 100x minus x equals to 14.646. Again, we have a dot on this number, minus 0.146, and then we have dot on these numbers. Let's try the subtraction separately. That's going to be 14.646. Again, we got a dot on these 2 numbers, minus 0.146, and then we have a dot on these numbers. This and this cancels out. That's going to be 6 minus 1. That gives you 5. 14 minus 0 still says 14. So on this side, I can say that we now have something which is not recurring, which is 14.5. And on the left side, we're having 100x minus x. That gives you 99x. Like I said, you have to realize in every other question, if you use this approach, it's very easy for you to tell whether you have to multiply this by another 10 or not. So I can clearly see that, as in it would be nice if I did multiply this by 10. So if that is the case, then we have 990x equals to 145. How did I get 145? Well, I just divided this. And again, if you start simplification, you would probably understand that in this case over here, I can start simplifying this by 3. I'm not going to use a calculator. So again, 3 times 4 is 12, 25. We can't divide 25 with this. So let's start another number. In this case, I think probably the easiest division is by 5. So if I divide 145 by 5, I know that's going to be 29. Similarly, if I divide 990 by 5, this gives me 198. Let me think if I can simplify this anymore. I don't think so. So that's pretty much it. We have 29 over 198 as my final answer over here. In a very similar way, let's try another question as well. So the next question seems a little more simpler because now in this case, we are having just one number that is getting repeated. So again, we'll follow the same strategy that we have. So 0.41, and let's put the dot over here. What does that mean? 4111111, right? If I were to multiply this by 10x, that's going to be 4.11111. Or in other words, I can just place the dot over here. Now that I have this, we can start subtraction. So 10x minus x is going to be 4.11. We'll place a dot over here, 0.4, and then we have a dot over here. So 4.11, and then we have dot minus 0.41 dot. This and this cancels out. Now we got 4. You probably know that you can actually subtract just like the way you have been doing before. 11 minus 4, that's going to be 7, and then we have 3. So you can probably see that we end up getting, in this case over here, 3.7 as my right side. And on this side, we'll be having 9x. Again, I feel like that it would be nice if we multiply both sides by 10. Otherwise, you could have taken the 9 over here and then converted this decimal number into a fraction. So multiple ways, but at the end of the day, we get the same answer. So there's no fixed method, I would say, in these kind of questions. That's going to be 90x. This would be 37. If I divided this, that's going to give me x equals to 37 over 90. Since we know that 37 is a prime number, that means the answer remains the same, which is exactly what we had. Again, let's try another one, which is x. Let's take x as 0.621. Let's place a dot over here. How many numbers do you see? 2, right? So that means you should be multiplying this by 100x. Again, there's no fixed, again, like I said, I just want to reiterate this thing that there's no fixed method that if you do it this way, then you'll get marks. I'm just trying to make sure that we work out something that is very easily, as in recognizable by everyone. So if I multiply this again by 100x, you probably can see that's going to be 6.2. Wait a second, that's going to be 62.1, and then we have 212121, which means that we'll be having decimal number over here. We can subtract this, so 100x minus x equals to 62.121 minus 0.621. You can clearly see that we can perform this subtraction, which ends up giving us 0 on this side, 1 minus 6, that's going to be 5, 61.5. So this will be 61.5. On this side, we'll be having 99x. Again, you can multiply this by 10, which gives you 990x equals to 615. And if I start dividing this 615 over 990, I can clearly see that the easiest division has to be with 5. So if I start dividing this by 5, that's going to be 1, 2, 3. Similarly, in the denominator, we should be having 198. This, however, would simplify more. So this would be 41 over 66. This, again, is my simplified answer. So hopefully this makes sense. With this, we come to an end. Let's catch up again in the next lesson with some other concept. Till then, adios.